Hi, welcome back to part 4, the final part of this review for test number 2. Hopefully you're getting something out of this, and if you got questions, please email them and I will do my best to try to answer them. So let's begin with the last component. So according to the principle of diminishing marginal utility, as consumption of a good increases, total utility decreases and then eventually increases, decreases at an increasing rate, decreases at a decreasing rate, increases at an increasing rate, and increases at a decreasing rate. For this particular question, you may want to think back of the graph that I sent you, the total utility curve and the marginal utility curve. Our answer here is E. It increases at a decreasing rate. Remember, you get your highest marginal utility of an item from the first item consumed. And when you consume the second one, your total utility increases, but at a smaller rate and so forth. Question number 6. Suppose that Jessie spends her entire income of $6 on nail polish and dresses. Nail polish costs $1 per unit and dresses cost $2 per unit. As per the table that will come up shortly, the marginal utility of each good is independent of the amount consumed of the other. If Jessie is maximizing her utility, what is her total utility? And here's the table that you have to work with. The quantities that are consumed, the marginal utility received from each nail polish consumed, and the marginal utility of each dress consumed. Okay, to answer this particular question, I have decided to use the formula to work my way through it. So you will recall that the formula states that the marginal utility of the last nail polish consumed divided by its price must be equal to the marginal utility of the last dress consumed divided by its price. Figure out a method, a logical method of going through the data, so pick and choose sort of an approach. And I will start off with the first nail polish, which gives me a marginal utility of 8. I'm only consuming 1 now. So 8 divided by its price, 1 is equal to 8. Then I'll go to the marginal utility table of the dress and I'll find something that divided by 2 will also be equal to 8. So if I take 16 divided by 2, it's equal to 8. They're both equal. I will accept it and continue. And now implement or use the data that I was using here and put it into the budget equation. You'll recall the budget equation is price times the price of the nail polish times the quantity of the nail polish plus the price of dresses times the quantity of dresses consumed must be equal to her budget of $6. The price of the nail polish is $1. I've consumed the first nail polish. And to that, I will add the price of the dress, multiply that by the number of dresses consumed, which is 1, and that must equal 6. So 1 times 1 plus 2 times 1 is equal to 6. 1 plus 2 is equal to 6. 3 is not equal to 6. Therefore, I will reject it. I will now go to the second nail polish and use the exact same formula. Plug in the marginal utility of the second nail polish divided by its price. It's equal to 6. I will go to dresses. What divided by 2 will equal 6? 12 divided by 2 is equal to 6. I'll accept that. And then once again, I will plug it into the budget formula. The second go around, I will once again use the price of nail polish, the number of nail polishes consumed, which is 2. To that, I will add the price of the dresses multiplied by the number of dresses consumed. I will add the two together and hopefully that will equal 6. I will do my extensions. I will get 2 plus 4 is equal to 6. 6 is equal to 6. I will accept it. Now, I do not have to go any further. This tells me when I consume the first 2 nail polishes and the first 2 dresses, I have maximized my level of utility because both the condition and the budget line or the budget formula agree with each other, or each separate agrees separately. So my answer is here, she buys the first 2 nail polishes and the first 2 dresses for a total utility of 42. The total utility that she receives is the summation of all of the individual marginal utilities. The 8 plus the 6 plus the 16 plus the 12 will equal 42. You'll recall we've done at least 2 or 3 of these problems in the notes and that I sent you previously. We'll go on to the next question. Here we go. If the price of a good measured on the y-axis increases, the budget line will what? Become steeper, become flatter, shift leftward but stay parallel to the original budget line, D, shift rightward but stay parallel to the original budget line, and E, shift leftward and become steeper. For a question like this, your best bet is to do a little thumb sketch of X and Y axes, good Y, good X, and draw in a budget line. So that would look something like this. Obviously, the price of X increases. This is the original budget line. It will rotate around the x-intercept and down the y-axis. So you can buy the same number of goods of X because X price didn't change. The price of Y increased. You can buy fewer with the given budget. Number 8, the principle of diminishing marginal utility means that the consumer surplus from the second slice of pizza is blank, or is going to be A, greater than the first, B, equal to that of the first, C, less than that of the first, D, equal to that of the first divided by 2, and E, equal to that of the first multiplied by 2. The principle of diminishing marginal utility, that's a hint. And hopefully you got your answer from here. And the answer here is C, less than the first. Second slice value is less than first, and because of diminishing marginal utility, consumer surplus is less. You're given this diagram. You got 2 budget lines, a S and T, and 2 indifference curves. The initial budget line RS to the right would shift to RT as a result of an rise in the price of good X, a fall in the price of good X, decrease in the preference for good X, rise in the price of good Y, and E, increase in real income. The answer is your income has stayed the same, the price of good X has increased, so it's going to rotate uh, around the y-intercept and move from RS to RT. Your answer here is a rise in the price of good X. With the same income, one can purchase less commodity X. Another question. Consider the budget line and indifference curve to the right. If the price of X is $2, what is the price of good Y? The point of tangency here is 3 units of good X and 4 units of good Y. I'm giving you some time here to figure this one out. Okay, try to, here we're going to go. It's a pretty long answer, I think, the way I'm presenting it. So the price of X is $2. If you only buy good X, then your total budget is 2 times 6. Remember, you can buy, according to the graph, 6 units of X if you spend all your money. Therefore, if you take the price of X and the maximum number of units you can buy, multiply them together, and you will get your budget. So 2 times 6 is 12. You're also going to have $12 if you buy only good Y. So if you only buy good Y, you spend $12 on 8 items. That 8, again, you read that off the graph. That would be the Y-intercept. And then you would have your $12 divided by the number of units. You could buy 8. So each unit of Y costs $1.50. So let's go back to the previous slide. You'll notice if you buy only X, you can buy 6 units. And if you only buy Y, you can buy 8 units. That was an important piece of information that you should have read off the graph. So right here, the 6 that we can buy if we spend all our money on X, and the 8 if we spend all our money on Y. And that's the end of your review. I hope that you got something out of it. I am sure you will do well on the test. If you have any questions, please email me and I will do my best to answer them. Take take the remaining time and study for the test. I will be posting other videos on the theory of production, cost of production, both the long run and the short run, and perfect competition starting next week. Okay, or maybe even this week if I get to do a satisfactory job on taping them. Good night. Thank you very much. Take care. Stay healthy. Cheers.